Good day, viewers. Welcome to the Physics Mind. Today we will be looking at another question from friction, and it's specifically NECO question 2007 AC question 11. Okay, so let's look at the question together. Now the question says that two bodies X and Y of masses 5.0 kg and 7.5 kg respectively are connected by a light inextensible string as illustrated in the diagram below. Okay, so these are two bodies X and Y that are a rough horizontal surface. X is placed in a rough horizontal surface and they are connected together by an extensible string that joins the two bodies together. Okay, and the mass of body X is 5.0 kg while that of body Y is 7.5 kg. Okay, so we are told that if X is placed on a rough surface of coefficient of friction 0.5, so body X is actually placed on a rough horizontal surface, and we are told that the coefficient of friction between this body X and the surface is 0.5, and body Y is left freely and suspended in air through the help of the string that is holding them together. Okay, and joined together over a smooth pulley. Okay, so we are asked to calculate the magnitude of the normal reaction on X. That means the normal reaction between this surface and X. And also we should find the frictional force between X and the surface. That means the frictional force that is existing between this body X and this rough horizontal surface. And lastly, we should find the tension in the string. Then this is the string, that is the inextensible string that is holding body X and body Y together. So we should find the tension that will be in the string. Okay, so let's start with the question. So the first part of the question says we should find the normal reaction. So we write normal reaction R, and of course we know that body X is resting on a horizontal surface. So since it's resting on a horizontal surface, now the weight of body X will be acting downward, whereas the normal reaction of the surface back on body X will be acting what? Upward. And remember that the normal reaction will be equal to the what? The weight of the body, since it is on a horizontal surface. So the normal reaction on body X will be equal to the weight, and which is equal to the product of the mass multiplied by acceleration due to gravity. So our normal reaction R will be equal to, now the mass of the body, we are talking about body X, and the mass of body X is 5.0 kg. So we have 5.0 times acceleration due to gravity G. We are given the question to be 10 meter per second square. So we have times 10. So 5.0 times 10, that will give us 50 Newton. So that becomes the normal reaction of body of the surface back on body X. Okay, so the second part of the question says we should find the frictional force between X and the surface. Now remember that body X is on a rough horizontal surface, and this is the tension, or this is the string that is pulling it in this direction. It means that friction will act in the opposite direction. So we are looking for this frictional force on body X. So secondly, we are looking for the frictional force F. So remember that the coefficient of friction mu is equal to frictional force over normal reaction. So that makes it 1 cross multiply. Our frictional force becomes mu R. So our frictional force now becomes mu, which is the coefficient of friction between this body X and the surface. And we are told that the coefficient of friction from the question to be 0.5. So we have 0.5 times the normal reaction of body X on the surface, which we've already calculated to be 50 newtons. So 0.5 times 50, So our frictional force becomes 25 Newton. So that becomes the frictional force. Okay, so the third part of the question says we should find the tension in the string. We should find the tension in the string. So this is the string that is holding them together. So remember that one end is joined to body X while the other is joined to body Y. So let's call the tension here T. But remember that this tension must be expressed in terms of body X and also in terms of body Y. Why must the tension be expressed in terms of body X and Y? Because it is joined to the what? The two bodies. So what we need to do now is we need to find an expression for the tension in terms of X and also an expression for the tension in terms of body Y. So thirdly, we are looking for tension. Let's call the tension T in the string. Okay, so we said for us to find this tension, we must find the tension in terms of body X and also the tension in terms of body Y. But remember that tension is actually a what? A force that exists in what? In stretch materials such as rope or string or cord or any material that is what? Is stretch. Okay, so we are looking for the tension. It means that tension is a force, and force we know is equal to the product of mass times acceleration. Force is the product of mass times acceleration. But then the force we are going to use in this case is going to be the what? The unbalanced force between what? For body X. Let's write it down that for body X, we know that force is equals to mass times acceleration. Okay, so for body X, now the force in this case is going to be the difference between the what? The tension in the string and the frictional force, because there are two forces acting on body X. So one force on this direction or in this direction, which is the tension, and the other force in the other what? Direction. Remember that when you have two forces that are acting on a body in opposite direction, so the total force acting on the body is a difference between the two forces. But the question is, how do we know which of the force will be greater than the other? Now, since the body have every tendency of what? Of pulling to this direction, because this mass is actually greater than this mass. So it has every tendency of moving in this direction. So that makes the tension that will be in this cord to be greater than the what? The friction in the between the surface and body X. So it means that this force here is actually the difference between the what? The two forces, which is the tension and the friction. So I'm going to replace this force by writing tension minus the friction to be equal to mass times acceleration. So that is the force for body X. Okay, so if that is so, I can denote my tension to be T minus my friction. Of course, we know that frictional force is equal to mu R to be equal to mass times acceleration. Okay, so when we substitute the values, we have our tension to be equal to coefficient of friction, which is 0.5 for body X, times normal reaction on body X. We've already calculated it, which is what? 50, to be equal to mass of the body, which is body X, which is 5.0. We have 5.0 times acceleration. We don't know what is the acceleration. So we have T minus 0.5 times 50. That will give us 25 to be equal to 5.0 times A, which is 5.0 A, or just 5A. Okay, so let's call this equation 1. So we have found an expression for the tension in terms of what? Body X. Now let us also do the same thing for body Y. So we'll write that for body Y, we'll do the same thing. We know that our force is equal to mass times acceleration. And the force in this case is still going to be the unbalanced force between the what? the tension in the string and the weight of the body. Remember that this body Y is suspended freely in what? In air. So there is no actual what? Friction. So the only unbalanced forces acting on body Y is the weight of the body itself and the tension in what? This string. Remember that the weight of the body will be acting what? Downward. Whereas the tension in the string will be tending to what? To pull it what? Up. So the two forces are acting in opposite what? Direction. So we need to find the what? The unbalanced force. That means by subtracting them. And of course, we know that the weight of the body will be greater than the what? The tension in the string, because the mass of the body is what? Is higher. So, and while this mass is what? Is lower. So there is no way that the tension in this string will be greater than the weight of this body. Okay, so for body Y now, the force will now become the weight minus the tension to be equal to mass times acceleration. And the weight of the body we know is mass times acceleration due to gravity, which is mg. Then minus our tension, let's call it T, is equal to mass times acceleration. So the mass of the body, we are talking about body Y, which is 7.5 kg. So we have 7.5 times acceleration due to gravity, which is 10. Then minus T is equal to the mass of the body, still 7.5, times acceleration, which is A, we don't know. Okay, so 7.5 times 10, that gives us 75. Then minus T is equals 7.5A. So let's call this equation 2. Okay, so we have equation 1 and equation 2. And from equation 1, we have T is equal to minus 3. T minus 25 is equal to 5A. And we can't find T from here because A, acceleration, is still unknown. The same thing here, we still can't find T here because A is still unknown. So we are going to solve equation 1 and equation 2 simultaneously in order to find the acceleration first. Then when we find the acceleration, we can substitute in either equation 1 or equation 2 to find the tension, because the tension in the string is going to be the same because it's connected to the two bodies. Okay, so we write solving equation 1 and 2 simultaneously. 1 and 2 simultaneously. So from equation 1, we have T minus 25 is equals 5A. And from equation 2, 75 minus T is equal to 7.5A. So rearranging it, I'll write it as minus T plus 75 is equal to 7.5A. It's still the same thing. So what I'm going to do is I'm going to add the two equations together. So adding them together, so I have T plus minus T, which is the same thing as T minus T, so that becomes 0. Okay, so minus 25 plus 75, that becomes minus 25 plus 75. So minus 25 plus 75, we have 50. Okay, so that is plus 50 is equals 5A plus 7.5A. That will give us 12.5A. Okay, so we have 50 is equals to 12.5A. So we are looking for A, the acceleration. We divide both sides by 12.5 by 12.5. So this goes with this. So acceleration becomes 50 divided by 12.5. So we have 50 divided 12.5, which is equals 4. So acceleration is equals to 4 meters per second square. Okay, so we've gotten the acceleration to be 4 meters per second square. So we can substitute the acceleration A, which is 4 meters per second square, in either equation 1 or equation 2 to find the tension. So let's substitute in equation 1 to find the tension. So we say put A to be 4 meters per second square into equation 1. And from equation 1, we have T minus 25 is equals to 5A. So we have T minus 25 is equal to 5. A is 4. So we have T minus 25 to be equal to 5 times 4. That is 20. So T will now become minus 25 cross to the other side. So we have 20 plus 25. So the tension now becomes 20 plus 25, which is equals to 45 Newton. So that gives us the magnitude of the tension T in the string. So you can substitute the same thing in your second equation. You still have the same answer for the tension. Okay? So by this, we've come to the end of the topic. Thanks for watching. Please like and subscribe to my channel.